Okay, welcome everyone to the second industry guest lecture in DSC 102. It's a pleasure to introduce William Falcon. He is the founder of Lightning AI. And William, thank you for taking the time to come and speak with the students, even if it is virtually. William was a US Navy SEAL naval officer, right? Before studying at, is that right?
Yeah, I was a naval officer. I went through SEAL training. I got injured, did not graduate, but spent a long time going through training. And then I was actually at a SEAL team for a few years after that as well.
I see. Okay. And then he went to NYU to grad school to start his PhD, funded by DeepMind and NSF. And he created PyTorch Lightning there. It's become wildly popular, used by many machine learning researchers and engineers in industry. And he's also worked as a researcher at Facebook AI and at Goldman Sachs, and co-founded a now acquired startup in AI called NextGen West. His research was advised by Kyung-Han Cho and Jan LeCun at NYU, the intersection of AI and neuroscience, focusing on biologically inspired research on deep learning and reinforcement learning for problems in neuroscience, NLP, and other social problems. So Will is here to share with us about production-ready deep learning at scale. And it's a good complement for some of the issues that students have been learning in this class. Production-ready systems, what does it mean to be scalable? And now they get to see this in the context of deep learning applications. Protocol for the talk. Students, if you have any questions, please post it on the chat. If Will, are you okay with taking questions in between, or do you want to wait till the end?
Yeah. No, I want it to be interactive for sure. I think it's how we learn the best, right?
Okay, sounds good. So feel free to pause in between and take questions as well. And I will call on the speakers. Folks, raise your hand first before you want to speak. Then I'll call on your name. With that, Will, all yours.
Awesome. Well, thank you for having me, Aaron, and I'm really excited to be here. I was really looking forward to going back to San Diego, so I spent about 6 years living there. So if I'm sure you're all aware that it's a big military town. If you've been downtown, I'm sure you'll see this. So yeah,
we also hear it every time. We have jets flying around almost every day.
Yeah, exactly. So I first got stationed in Coronado. So if you guys have been to the Dell, just south of the Dell, there's where Buds it happens, and then there's a bunch of SEAL teams down there, right? So I was going through SEAL training for a few years, and went through Hell Week and got injured coming out of it, and then basically got put up in a SEAL team for what was supposed to be 6 months to heal, because you have some process to go through that. And this was around 2013 when the military pulled back out of Iraq, and they basically looked around and they were like, if you have some people floating around in like these injured spots, you have to figure out if you're going to do something else or get out, right? So they were like, we're not going to let you go back and finish. And I was like, well, I don't know. You told me I could, right? So the option was become a pilot, intel officer, or leave. And so I left, right? Although maybe if I'd seen Top Gun, I would have become a pilot, but who knows? And so I stayed in San Diego for a few years, and still living in Coronado, and then moved to like Fashion Valley area for a bit, right? So from there, I kind of taught myself to code, because what are you going to do once you leave the military, right? So I didn't really have a plan B. So I was trying to figure out what to do for a job, and then really got into coding, right? So if you just started, I mean, none of you guys have started, but if you just started like a year ago, I promise you it's fine. I started coding when I was like 26. I didn't write my first neural network until 2013. No, not even 2015 actually. And then you can learn a lot in like a few short years, especially if you go to startups, right? So I left the military, and then I went to Columbia and actually did undergrad there, and then stayed in New York and went down to NYU. And there's a lot of neuroscience actually at San Diego, right? And so it's actually a big lab, and we collaborate closely with a lot of labs there as well. So I have a big passion for that. So I really got into deep learning from that side, right? And if you're coming from science, like I don't know, anything engineering, like biomedical engineering or like protein folding or whatever, you actually need to make systems run pretty quickly. Like it feels like, but I'm in research, I'm a PhD, or I'm working at Genentech or whatever. It's actually pretty critical that you run things quickly. And then a lot of the times your things may not get deployed, like a Genentech, for example, your output is going to be a DNA sequence. That's going to go to an actual lab where that's going to synthesize some molecules, right? Or a drug. So it's not like there's like a deployment server running, right? But in some instances, like a Goldman, you might be high frequency trading where there is a server running and that thing needs to run in like milliseconds, right? And so just remember the word deployment means more than putting something behind an API, right? And so, and I want to make sure this is interactive. So if you got so many questions, let me know, right? So, when I was when I was still an undergrad, what I was trying to work on was iterate on how to go between research ideas very quickly, right? And without rewriting a lot of the code. And it turns out that that code became what is known today as PyTorch Lightning. But what was the fundamental insight, I guess, or it just took like 5 years to make, right? And then it was open source in 2019. What was interesting is when I started at Facebook, so I went to Facebook at Research to just do my PhD there. So if you work with Jan and Cho and a few advisors, like you tend to go to Facebook and just kind of work out of there for a few years. So at Facebook, I was trying to train on YouTube and we were scaling up these models, right? And we were using like one model I would run on like, I don't know, 1,000 GPUs probably, right? Pretty consistently. And I would run like 5 of those. And when you're running things at scale, you know, the probability that any one machine or something fails gets a lot higher, right? So, and the clusters usually, and even production systems will have sometimes limits, right? Where, you know, if you use AWS, for example, there's something called spot instances where you'll get a machine at like 1/10 of the price of a regular machine, but it can be killed at any second, right? So the only way you can use that is if you build in fault tolerance, right? So there's a lot of interesting things that you actually have to build in to actually do machine learning at scale, to productionize things, to deploy, to train, and so on. Nowadays, machine learning is not just about deploying a model. There's actually a lot more to it because sometimes you're deploying multiple models. What if you're like, for example, if you're doing reinforcement learning on a game, how do you get the game to be really fast and work with that RL system when the RL system is on a separate machine, right? So all of that to say that the stuff that we've been working on for the last few years is how to make that stuff really, really fast. And that's what PyTorch Lightning evolved into what is now called Lightning AI, which I'll talk about what those principles are, right? So to make this fun, before I go into the slides, I want you all to go to this app called Muse that we introduced, right? Oops. So it's lightning.ai/Muse. And if you guys have heard of Stable Diffusion and stability and all of these generative art things and OpenAI DALL-E, this is a Lightning app, right? Now this is, if you click on it and you use it, it's going to, you know, give you an image based on what you typed in. So this is a product that we released to show people how to build something like DALL-E and the Stable Diffusion stability product in a very quick way. So a lot of enterprises need this kind of stuff, right? So if you're going to launch a company, you're going to launch a new product, this is a really good template. And I'll actually walk through how a lot of this stuff works under the hood, so you can understand, because there's like load balancing happening, there's dynamic batching, there's a lot of like GPU inference and really interesting things as well. But the main idea here is that when you want to build production systems, you can actually start from a template that already has most of it embedded, so that you can then tweak the things you want, right? So to be able to run this particular app, I'll show you guys how to do that. But basically, if you go to lightning.ai and you click here, you can actually just select it, click deploy, and then it'll actually deploy it on an account. And you get free credits, right? None of this you have to pay for to actually do this. And you'll get a version of this app running on infrastructure on the cloud, right? So I guess what I'm saying is, you know, a lot of the code here is really good to look at to figure out how these things are done. So a lot of these things are built by engineers who are really good at like load balancing and so on. Now, what's interesting is, sure, this app is kind of like, well, there's DALL-E and stuff, right? So it's not really a big deal. What's interesting is that this app was built in 2 weeks. That's the difference, right? So the framework, the key thing that we enable and all our tools enable is for people to iterate very, very quickly, right? So you don't need $100 million and 200 engineers to build something now. You can actually do, as a solo person, you can actually build a pretty complex production system. So I'm going to talk about kind of how production systems are built today, and then contrast that with a lot of the stuff that we've introduced as well, to show the key ideas, right? So If you guys have been thinking about DAGs, have you guys worked with, I'm sure you work with DAGs at some point. So
yeah, they do programming assignments with them too.
yeah, so I'm going to show you why there are limitations to DAGs and how to get around them, right? So I just mentioned what Lightning is. So if now you know what Lightning is, it's the ability to train models and deploy them and to build full end-to-end machine learning apps, right? I just mentioned my background. I'm actually from Venezuela, so if anyone's from Latin America, hello. We talked about this already. And I mentioned why would we build Lightning, right? It's because we were trying to do something at scale in 2019 where the tooling didn't really allow it today. So today you guys can train like videos on thousands of GPUs, and it's a lot of it is foundational. It's now driven by a lot of the stuff that we introduced in 2019, and through the rest of the open source community, of course, and PyTorch and a few others. About our company a little bit. So we've raised about $90 million so far. We're roughly 50 people, mostly located in San Francisco, New York, and some people in Europe. We have over 400,000 active users around the world that use our products, that build things with Lightning. And we recently started a PyTorch team as well. So we're actually starting to innovate in PyTorch itself, where we hired one of the core leads in PyTorch from Meta. So I mentioned you can train models, you can build and monetize SaaS products and so on. So I'll skip all these. Basically, this is just showing some case studies where Stability AI, for example, the company that just launched Stable Diffusion, the Dream Studio, everything's built on top of Lightning there, right? All the models, everything they've trained. And then, not Lightning apps, but the actual model training part. And then this is how AWS just published this a few weeks back, showing how they use PyTorch Lightning to power Amazon search, right? These are two examples. There are many, many companies, including Meta and so on, that run on Lightning. And so I'll skip into the lessons that we've learned, right? Okay, so if you're trying to put machine learning into production, right, you're gonna need this complex chain of tools, right? And it's interesting because like when you're doing an assignment, or maybe you start doing machine learning in production, you're kind of always going to start in one of these spots. That just depends kind of where you are, right? Like if your company is not super advanced with it yet, you're probably going to start with the gathering data part and the data prep, because you have to like go into servers and logs and pull the stuff out and make sense of it. So you're going to spend a long time there, and then you're going to do data wrangling, all of this until you actually get to the model. So this kind of will feel pretty easy after this point, right? Now, in some companies that are more advanced, there's already like feature stores and all these databases that already have done this for you, and this kind of automatic, and you can actually jump to more of the model training. So then if you're kind of like, if they've already solved this for you and you start doing this, you're kind of going to run into issues with this part, right? And then in some companies, if they're really, really advanced, like Meta, you might have the whole thing kind of already figured out, but it'll be pretty like, I don't know, how do I say it? It'll be pretty annoying to use, right? Because you'll have to like log into some server, do some, launch some script, and then log into another one, launch some script, make sure you do it correctly. So it gets really hard to maintain and to observe the systems, right? I think that the fundamental principle I want you guys to think about when you're building production systems is observability and understanding what happens in that system, right? So it's one thing to build a system, but when something goes wrong in that system, it's another thing to figure it out very quickly. There's a story, I think it was Robinhood, right? So they had the scandal with the meme stocks, and I was talking to one of the engineers from there, and this person, I think, was the person on call when this happened. So his beeper went off, and then he had to basically try to stop this whole thing from happening, and they were able to do it pretty quickly, right? But imagine every second that they were delayed literally cost them like $10 million, something insane. So the ability to respond and understand what a system's doing is super, super powerful and super valuable depending on the type of industry you're in, especially in finance. So where we started in the cycle is PyTorch Lightning. So PyTorch Lightning, the repo that I showed you here, where is it? Yeah, here. So it's now called Lightning because we evolved beyond training, basically helped you, and it still does, it's still in here, but it helps you train models, right? And so what we were solving in the beginning was this ability to train models. When you're training models, the biggest thing that you're having to deal with is how do you not lose flexibility so you can actually try really crazy ideas, but also be able to take it to production, right? So there's a trade-off. If you want the most flexibility, you're not going to be able to productionize it, guaranteed, right? So if you're an academic and you're in research and your PhD, you've never dealt with this, so it doesn't matter to you. But I'm telling you up front that the code that you're going to write, it's going to be great. It's going to be like super unstructured and it's going to be fun. But if that actually wanted to be used in production, you won't be able to, because there's no structure to it, right? It's kind of like you make your own go-kart and then you try to drive it at like the Grand Prix. Like, that's not going to happen, right? You need like a professionally built system to do that. So what we did is we basically built the professional system, which is PyTorch Lightning, but we gave you the ability to change the code that you wanted inside. So it's like a little window, and all the code in there is complete flexibility. So you have the ability to do everything. Now, if you want to do something outside of that, you may not be able to, right? And we have other tools that allow you to do that. But the trade-off that you're getting is that, hey, you still have full flexibility, but they can actually be productionized and scaled, right? So these are things that people need to think about as well, right? So any questions so far? Anyone's like run into any kind of model training or like done something at scale? Like, has anyone trained models? Start there. Has anyone trained models? Like, I'm sure this has happened, right? All right. Has anyone trained models on more than one machine? Okay. What's the max number of machines you've done it? 16 machines. Okay, and the what, like 8 GPUs per machine? So 64, 128, something like that. You guys have a big cluster, I assume? Oh, 16 GPUs. Okay, so it depends on the machines, right? So you might have 16 machines that each one has a GPU, or you might have 2 machines that each one has 8 GPUs, right? The configurations actually matter a lot, right? Depending on the cluster and how you set it up. You could have, for example, on AWS, there's certain machines that actually can have 16 GPUs. They're like T4s, I think. We're pretty old GPUs. Maybe there's like a V100 one. So 16 GPUs in one machine. That's probably the most optimal scenarios when you have all the GPUs in the same machine. And the reason why that works really well is because the latency between the GPUs is basically negligible. So if you guys have ever seen a GPU, right, let me just show you. V100 GPU here. So if you look at the GPUs, they actually have, this is like a little box like this. They actually have a little connector, right? So when you put it into a machine, this is like a consumer machine, but on an enterprise server, you see there are 4 GPUs here, right? So you can actually connect them with something called NVLink, if they're NVIDIA GPUs, that will actually allow the GPUs to speak directly to each other, which means they don't have to go through the CPU, right? And then the motherboard and all that. So it'll be a lot faster. So basically, if you can literally connect all of them together, then it'll be really, really fast. Now, when you start spreading across machines, now you have to move stuff across the machines, and that's going to kill the performance, right? So a good analogy is like these GPUs are like Ferraris at this point. They're super fast. Now, if you have really bad connections between the machines and you want to train on multi-machines and you put these things on there, it's like driving a bunch of Ferraris inside New York City. Like, it's not going to work, right? It's like cool, but like you're kind of wasting the purpose of the Ferraris, right? And so the connects between the machines is super important. So there's something called Fabric that NVIDIA uses as well to make that happen. And cloud providers provide their own, right? So, the way that you can think about optimizing training specifically is how are you doing in a single GPU? Then how are you doing in multiple GPUs on the same machine? And then how do you do across machines? And how do the GPUs communicate with each other inside the machine? And how they communicate across the nodes, right? So the machines are called nodes. So it's a lot of stuff to think about, right? So these are just things that I think are interesting if you're really trying to optimize training. Obviously the good news is like there's a lot of tools out there, and we're one of them that allows you to just basically out of the box get that performance. And you can actually tweak it and test and things like that. But there are many other great tools. Again, all our stuff is open source, so you can see the code itself and see how this works. And we'll even do it on the cloud as well, right? So there's a lot of stuff that goes into it. So it's really fun if you want to experiment with it. So I'm showing some GitHub Star. This is like our GitHub Star growth compared to some other popular projects. Lightning's a pretty new project. It's only a few years old. But Kubeflow, Metaflow, for example, are like some of the oldest projects around. And they basically have, if you see the trajectory here, they're not quite super related. They are. It's more just for showing the speed of it, right? GitHub stars generally. So if you guys are, I guess maybe hopefully you guys use open source, but GitHub stars are a way to understand kind of the popularity of a project. I will say GitHub stars does not necessarily mean it's a good project. It just means that a lot of people know about it. And it also does not mean it's used a lot, right? What you want to look at is actually downloads of the project. So you can go to PyPy or whatever and see what the downloads are. Lightning is downloaded roughly 4 million times a month right now, right? And it's, like I said, used across a lot of companies. So the way that we've approached this problem of scale, right, it's organization. So I think the first principle you have to understand is organizing code, and it doesn't have to be with Lightning, just in general, having standards between the parts of the system actually is what allows you to scale things, right? And so this is kind of the option of what people do today with regular PyTorch, right? So what you can do then, the other option is you basically just buy an API, right? And this API usually will kind of just give you the stuff out of the box, or you may build this yourself, right? So if you build it yourself, then you may have the performance tweaks there. So like I mentioned, what we wanted to do is give the people the ability to basically say, hey, I'm still going to have that flexibility, but I'm going to provide that organizational structure, right? So this is a structure that we provide, and you can always come up with your own, right? This structure took us about 5 years to figure out. And the way that you put it together is basically you have in your inits function, you can actually pass in the models. So this is simulating again, well, it's an action, sorry, it's a VAE. So you can pass in 2 models. Nowadays, it would be like a diffusion model would actually have 3 types of models in it. Transformers, all this stuff would be kind of like working together. The forward method is kind of like what happens, if you understand backpropagation, it's kind of what happens in the forward pass of that, where you're computing all the activations, right? And then you're going to calculate the gradients after that. And then the training step, what we've basically done is we looked at the whole training and we said, you know what, none of it matters, honestly, except what happens for each batch of data. So in each batch of data, we're going to give it to you. Now you tell us what you want to do with it, but the rest we're going to handle automatically. So that structure allows scale, right? Because it means that if I implement something like TPU training in my code at the fundamental framework level, the next thing I write actually already has that feature too. So it's how you're actually able to scale between teams and projects, right? So remember, like a lot of this, when I started was exactly in academia, hey, I'm doing like a research project, and then I'm going to do another one, but I don't want to refactor as much as I want to minimize the amount of code I refactor, right? You may actually do this yourself. So maybe some of you guys have code bases I use for homeworks, and then you tweak them and you just change something about it for the next homework, right? So if you do that process for like 5 years and then you write it into a framework, you're going to get something like this, right? And there's a few other frameworks, right? It's not just Lightning. So now that's just the model, right? So what we've now kind of worked on is this glue layer, right? So this pink stuff. This is what's normally handled by like DAG systems and so on, right? And so these are things that you kind of need to understand as well. And I'll talk about them a bit. This is our take on that. And this took us a few more years to figure out. But we've actually modeled it after React, right? And so I know it's a little bit weird to think about. If you ever worked on React.js and builds web apps, it's actually a really good paradigm for building distributed cloud systems. I'll explain how this works and kind of contrast it to what people are doing today, right? So any questions before I go into this part, or any thoughts or comments? Because we're leaving training behind. So if you have questions about training, this is the time.
I guess not. So we can keep continuing and probably take questions later.
Okay, sounds good. All right. So again, if you go to industry, well, actually, that's a good question. Are you all going to industry, or some of you going to, I guess, who's going to academia? Raise your hand. Or you don't know. Okay. 1, 2. Yeah, great. Well, I have good and bad news for you. You still have to deal with software in academia. But the good news is, it's actually funny because a lot of the software that's been written for like production systems actually came out of like PhDs, NumPy, sklearn, what do you call it, Hadoop, Spark, all this stuff, right? It's so don't get discouraged if you like end up writing some esoteric library because there's nothing out there. Like that's probably a good thing actually. So in industry, people tend to write their stuff a lot as well, right? Now they don't tend to literally write from scratch. They tend to kind of stitch things together, and they tend to put tools together. And the way they do that is through these kind of YAML systems, right? Which I'll go into YAML in a minute. And then the other option is to buy a platform, right? So these are just not super flexible, and some of these are open source as well, but it means you have to tailor your workflow to what they're doing, but you might not want to do that, right? So I mentioned in the beginning that PyTorch Lightning help people standardize things. So again, we're going to apply the same principle because we need structure to productionize things, but we're going to allow you to build your own systems now that are actually end-to-end. So Muse that you just saw, it's a complete end-to-end product, right? So let's look at a Lightning workflow. Well, actually, let me step forward before we get into it. Yeah, let's see here. I want to talk about this. Okay, so you guys know about DAGs. I think this is the fundamental principle here. So DAGs are sequential processing of things, right? So I say, hey, I don't know, process some data and then take that and put it into a model, maybe two models, and then take one of those and deploy them, right? So it works in a lot of use cases. Now the problem, and this is kind of what machine learning has been built on today in industry, right? Mostly because it came from DevOps, right? So ML in production is like 5 years old, right? So no one knew what to do and how to do it. So a lot of DevOps engineers who have been productionizing like web apps and just regular backends basically were like, well, I feel like DAGs will work for this, right? So they used it. And it's worked so far, but it actually causes a lot of issues that people don't understand they have, right? And they tend to run into them a few years down the road. And because AI is so new in terms of adoption in industry, they're running into those issues like today, like this year and last year, right? And so now you're seeing this thing called MLOps. Oh my God, MLOps is so hard and blah, blah, blah. I think MLOps is a garbage name, right? I just think it's like, it's just a Band-Aid. It's not something that we should really even be focusing on. So it's just like, it's something that's happened because the tool is not appropriate for the job, right? So the thing that's wrong with DAGs, right, is usually specify DAGs through a YAML and maybe even code as well. But there's like fundamental flaws in DAGs. Like it's a acyclical graph, which means I cannot for loop it. I can't do while loops. I can't do recursion. It's not Turing complete, right? So Turing complete means that I can express a full, like the language has a full expression. I can express any arbitrary program with it. And a YAML file is definitely not Turing complete, right? And so it's really, really hard to actually build these systems. And even the libraries that come in they're Python, but they're really, really complicated. And so you actually end up building a lot more unstable systems and more complicated systems because of these natural limitations that happen by the fundamental design, right? So when we were looking at this and we were saying, okay, but we want to allow people to solve the major problem, which is building end-to-end machine learning systems that require all those pieces that I mentioned, the data labeling, the deployment, all of that. But we don't like this approach because of these fundamental problems. So for a long time, we kind of like sat there and thought about it. And then what we realized was that what we really needed was something like React, right? We needed to take the state and actually not make it just push through the system, but actually have it be reactive to what the system does, right? And so if you've worked, well, I'll explain how this works on Lightning. It's the same principle in React. So you have this class called the flow, and in the flow, you describe your program logic, right? This is what normally we call an orchestrator, right? So you just say, hey, I don't know, put this model on this machine, put this other thing on this, and you do like for loop. I want to spin up more machines, shut them down, whatever. So the flow is what actually does the orchestration, right? And actually manages the system. And it's a Python class that you implement. Now the flow manages these works, and the works are the things that are actually doing the work, right? So work A might be training a model, work B might be doing data labeling, work C might be deploying a model, and so on. Now, this is not a DAG now. Now I have a single source of truth which is now being pushed to the whole system at once. So this is literally represented as a dictionary in Python, which means that every one of the works gets the state of the world as a dictionary. So it's kind of like what I'm doing right now, broadcasting to all of you. You're all seeing exactly the same thing, right? So I'm sending you the updates for everyone. Now, if someone were to send me a direct message now on a private chat, then I could take that and broadcast that back to all of you. So that's how it works, right? Whenever a work changes something about itself, it'll actually broadcast those state deltas back to the flow, and then it actually gets distributed, right? So you build this kind of top-down dynamic approach where anything in the system can change at arbitrary times, and then it gets picked up in the next loop, distributed, and then everything gets it again. This allows you to build infinitely complex systems. This allows you to program it. This allows you to build it like an iPhone app. It's funny because my analogy for why DAGs are bad in the world of ML is because, like, imagine you were like, if you use Twitter or Instagram or something, if you opened it and every time you have to do the same 4 steps, it's like open, click, 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 and then, oh my God, I messed up. And I have to go back to the beginning and do it again, right? Like, that's not how systems are built. They're reactive. They're kind of waiting for you to do something so that you can actually go and do and kick off arbitrary parts of the system, right? And so now we've introduced this paradigm and it enables the flexibility. So with any questions about this, because then I'm going to actually go through the code and show how this works. All right. I definitely did not explain that clearly, so it's okay. You can email me questions later. Statelessness. Yeah, no, that's not something that we care about so much. I guess there is a sense of it because the dictionary that gets distributed to everything has all of the states of everything. So if you look at the state dictionary, it'll actually go through the chain of the tree, and it'll say, oh, flow child 1, child 2, child 3, child 4, child 5 that work has X became 2 from 1 and the system failed. And so you can actually do that, right? Yeah, so we have hooks as well. I mean, basically we have this ability of having run. So it's a lot of the same principles, which I can point you to the docs as well. So React got pretty complicated over time, but the fundamental principle of like render in like the React function is a run method, right? So it's exactly the same. You just describe what you want to happen. So in your work, the render might be kick off a job on AWS SageMaker, or train a model in this thing, or deploy a thing, right? And so that's what you would do during the render, or literally call a sub process and just, like, I don't know, run an R script or something, right? So that's that. Statelessness, something. Is there any inefficiency associated with managing a broadcasting state like this? If we have hundreds of tasks, for example, yeah, 100%. It's depends on the system. Now, we obviously spent a lot of money building this. And so when I run things on the cloud, right? So when I did this here, if I were to like deploy this Muse app right now, so I'll actually show you this one. So if I hit deploy, now all of this kind of hosting and everything that we're doing here, this is kind of the product, right? And so this is the thing that where we handle all of this efficiency. So we take the open source and then we run it really, really optimized at scale in the cloud. And this is mostly for companies and students and things like that. But so it's automated there, right? Now, when you run it yourself, you do have to deal with how do you distribute state deltas across? How do you make it efficient? How do you cache? How do you make sure that these things happen quickly? What about fault tolerance? Because the machines go up and down. So it's really complicated. The inefficiencies are going to come in how you set up the networking for sure, and then how big the state deltas are. So we force limitations, right? You can't like send a terabyte of data through the state deltas. That's not going to work. So we actually lazy point to everything. So for example, if I download a data set and then I create a data set variable, then the variable itself is actually just a pointer to the data. And then you can, as you pass the state around, the second it gets actioned, then we actually move the data and stream it to whatever it's doing, and then we start consuming it, right? So everything's lazy loaded as well. Let's see what else. How do you find the state structure most affects workflows productivity in practice? It's definitely like you have to kind of get used to it. It's kind of like you start coding in React and there's like a weird gap because you're like, it feels weird because it's like kind of happening at the same time. It's like you can see the past and the future. I don't know how to describe it. So But once you get into it, it's like kind of hard to go back to not doing it. So there's definitely a bit of a learning curve there. But if you use things like Streamlit, like, it's already kind of common in Python. So I think people are already starting to get into it, right? I personally like it. I actually don't like it in React.js. I mean, I could React when I need to, but I actually don't like it. But in Lightning, it feels a lot more natural because it's simple. It's a lot like we don't have all this crazy JavaScript's insane. and you have all this networking stuff, all these like promises and things. We actually on purpose try to minimize all of that. So by design, we made it a lot simpler. So, we like embedded, basically it was like Redux embedded in here and all that stuff. And so I can walk through the code of how this works while this spins up, right? So this is kind of doing its thing. Actually, that was pretty fast. So now if I open this, like this is running, right? So the whole production system's already spun up. You see all the machines, logs, everything else, compute, storage, and then the distributed file system that's under the hood as well. So you can do this yourself, but it's obviously going to be a little bit of work, but I think it's obviously a good challenge for people to try. And so let's go through the actual code itself, and this is how kind of what it looks like, right? So I'm going to show you kind of like a hello world example just to understand. Yeah, so to auto provision of structures, Lightning use third-party tools. Yeah, depends on the cloud provider, depends on how you're setting things up. But we actually allow you to use Terraform if you want to, right? So when you create the clusters, so when I'm running this right now, so this here is running on the Lightning Cloud, right, which is backed by AWS. So if I see the cluster, this is the public cluster. So if you all go right now and this is probably a cheap one that you can try. This is just like a Gradio demo. If you deploy this one, all of us are sharing kind of the same cluster, right? Now you have different partitions and machines, so it's all safe, but nevertheless, we're all sharing the same cloud. So all of the auto provisioning is happening through here. Now for people who want to control their own clusters, we do have a feature that you can use, and you basically go create a cluster, right? And then when you create the cluster name is here, and you can actually change it here. You just say, hey, I want to use my other cluster, and then you actually run on that cluster, right? You deploy the thing on that cluster. And so under the hood, we have a command called lightning create cluster, where you can actually just create it and provide the provider. So we have publicly released AWS right now, and then you pass in the information, and it happens. But if you actually want to use Terraform yourself and specify everything about the cluster, you can actually do that, and we give you the mechanism to do that as well, right? So is there a good way for primary tuning in Lightning? Yeah, I don't have the template here, but we actually have an app that you can literally kick off like this. You can, by the way, you can run all these apps locally as well. So you can run them on your laptop for free. So if you want Stable Diffusion deployed to your laptop for free, like here it is, right? So yeah, so there is a hyperparameter tuning app that we're going to be releasing pretty soon. There's already components, so you can kind of see how it's done, but it's here, right? It's pretty straightforward. Multi-node training is also pretty simple. Let me see if I can show you guys that. Let me pull this up. I'm just putting this stuff together. Yeah, so here. Again, everything's open source, so everything that we do, we always want to get back to the community. So this is a Lightning app that does multi-node. It's pretty straightforward. So you're not building these apps most of the time. You're going to be consuming them. So it's these lines of code. So I can't see because my laptop's in the way. You basically pass in a Python script. You say how many nodes you want and the type of GPUs you want. And then we're going to go and orchestrate all that stuff for you automatically, right? So I'll actually post this app so you guys can use it as well. Well, actually, it's here. So if you guys want to check out this code, it's open source. Where's the messaging situation? Yeah, I don't know how to message on this thing. Okay, well, next time. This is Zoom, right?
You can post it on the chat.
Yeah, I'm just trying to find the chat because the thing is hidden. Where'd it go? Oh, here? No. Okay, well, I'll maybe send it to you guys. Oh, I'm seeing the chat. Like, where's the chat? Yeah, it's so weird because I'm obviously reading your chat, but then it disappeared as soon as I click. Can you send a message? Maybe it'll come back. Clearly, I don't use Zoom all the time. I'm like a Google Hangouts guy. No. Where are you, chat? Let me stop sharing for a second and then see if I can come back to the chat.
Okay, it's fine. I think we can post it on the chat later. We can continue.
Oh, here it is. It was hiding. Okay, cool. All right. So we'll go back. Let me move this thing here. So yeah, so I was just explaining how it actually works now. And so basically you're going to define this workflow, right? So you basically subclass this flow. And when you do that, you then basically bring in your integrations, right? You can write these yourself, and I'll show you how to write one. It's very simple. You just implement a run method. So you can literally print hello world, and that's it. Now in that integration, you basically are going to link them up together. This is kind of like connecting a bunch of USB drives to a machine, right? You just say, okay, I want to use all this stuff. And these, we have a lot of open source integrations as well. So you can, like, if you guys do data labeling, for example, we have like a label studio one that you can run yourself. And it's actually pretty fun because you get the UI and all of that, and you can use it to like collect data for research. Then now on there, if you don't put anything in this, when you instantiate this class Lightning Work, we're going to run in CPUs. If you want to use hardware, you can pass in this cloud compute argument. You can say 2v100s on, you wouldn't put a cluster because you'll probably be using the Lightning Cloud. Or if you do create your own cluster, then you can do that with your own Amazon account, of course. And then you decide, you say, hey, this piece of work is going to run in this infrastructure, and this piece of work is going to run in this infrastructure. Now, this is where we orchestrate, right? So the way that this is written right now, it's blocking, right? So this basically works like a DAG. This is a DAG right now, right? So I run this thing, which could be like train a model. And then if something happens, then I run this other thing, right? So this is working as a DAG. If I put in dot parallel, so I just say comma parallel equals true here and here as well, it's actually going to run async. So I say integration run, and it starts and it immediately goes to the next condition. So then the loop continues because nothing's happening, right? So then this is happening in the background. And then as soon as this variable becomes true, then this actually kicks off, right? So in these 4 lines right here, if this was train model and deploy model, what you actually have is continuous training and continuous deployment all at once. To do that today with the YAML and all the things that people use, it's like impossible, right? So it's a very expressive language that you can use now as well. So here is an integration, which is Jupyter Lab. So you can just run a Jupyter notebook. And the way that you do the integration is you basically subclass this Lightning Work. Is this big enough for you guys? I can zoom in if you guys want. Yeah, let me blow this thing up so it's easier to understand. Okay, so you basically, yeah, okay. So you implement this, you subclass Lightning Work. In this particular case, we do enable it by default because you don't want the Jupyter Lab to be blocking in the system, right? So you enable it. And then as you run, all you're doing here, notice it's mostly like opsy type of stuff. I'm running some commands on the CLI. I'm spinning up the notebook. I'm setting some passwords, some ports and stuff like that. And then I'm kicking off a sub process in Python to do this. And then that's actually going to spin up the Jupyter notebook. And in fact, we enabled in this particular notebook, you can actually run R and Julia as well, just simply by passing an environment variable. So this integration is probably like 200 lines of code. It took probably a few hours to write, but now you can literally have Jupyter notebooks and anything you use, right? So I think that's the power of the modularity. And I think that's the second kind of principle. Well, there's a few that I've spoken about already, but modularity is one that actually most production systems ignore. And that means you're doing a lot of work over and over again. So again, we have a list of these components that are open source, and so you can use all of these for free and add them to your apps and do whatever you want. They range from everything from like, spinning up notebooks, hosting Markdown posters. This is hyperparameter suites. This is really cool. This actually lets you process a video in real time and extract features from it. So you can search inside movies, for example. So we have an app that shows you how to do that. BigQuery, all the messaging stuff, so you can build like chatbots and stuff. This is an API access component. where you can basically, you just get like a UI, and all you have to do is pass in like an API front end, and you'll get something like this, right? Let me show you, it's right here. You'll get like a UI that looks like this, where you can actually use this endpoint anywhere you want. And then there's what else? There's something about performance. So this will actually load test the models. Now you just pass it in, and this will just smash the system and see how much it can handle in terms of load. And then you can do monitoring data drift. Again, these are community driven as well. So if you guys, you can write your own, you can make them open source, you can contribute back to the community so other people have them. So these are actually contributed by community members as well. And yeah, the whole idea is that you write them once and then everyone can benefit from them, right? So the whole premise of Lightning at the end of the day is that we want to take the best in class from research, from PhDs all over the world, from academia, from the best production systems, and put them together. And that's kind of what's already allowed PyTorch Lightning to be very successful, is that it's had over 700 contributors put in their best ideas into it so that we can all benefit from it, right? So it's like ML apps for all, by all type of vibe. And then, like I said, so you take that Jupyter component and you basically integrate it here, right? So this is another, you know, I don't hate DAGs. I actually think that they're complementary. And here I'm showing how you can embed a DAG into a bigger system, right? So here I'm running annotations. When I have enough annotations, I actually kick off a data pipeline. And then when this data pipeline is done, which will be blocking, then I'll have new features, right? And then when that's done, then I can actually train a model. And then as soon as there's a checkpoint, I can continuously deploy. So all of this is expressive, and there's a loop that's happening under the hood. So once you kind of start thinking this loop thing, it becomes pretty easy to work with it, right? We talked about the infrastructure already, YAML, all this stuff. Like I said, you can use Terraform, and yeah, you can orchestrate the most complex stuff. We talked about this. Again, this is a fundamental idea that makes all of this work, and why it's different. I know it's funny because, like, you know, I'm sure you guys have seen this from academia. When you make something simple, it's like, well, it's obvious, but it's like, well, no, it takes many years to make it simple, right? So hopefully you guys can use this stuff pretty easily without running into problems, right? So remember this code in the beginning that I showed you, which is PyTorch Lightning. Well, it's a lot of the same ideas where we have these templates that you can actually implement, right? Here, you can even break this up, right? So people don't know this, but today when you're training models, like what they try to do is this, they try to stick it all into one class, but actually these can be works themselves, right? Because the data download might happen in a different, if you're doing academic stuff, it is probably overkill for sure. But if you're actually going into industry and you're starting with prototypes, you can immediately put it into works so that by the time that you change from MNIST to like a real production data set, then all you have to change is one part of the system and you know the rest works, right? Yeah, so that's kind of a high level overview. Yeah, so let me, okay, found the thing. So let me show you the docs, good question. So if you go to Lightning here, you can go to docs. So the docs for PyTorch Lightning, so if you're training models, you can come here. And what I will do is follow this Lightning in 15 minutes. And at the end of it, you literally just copy paste this and you'll be able to train a model on GPUs, TPUs, IPUs, 5,000 GPUs, whatever, right? As long as you can, you know, provision the machines and all that. And then if you want to learn about Lightning apps, where you're actually building stuff on the cloud, then you go here, right? And then Lightning apps are here, and you just follow the same kind of apps in 15 minutes. This will explain to you at a higher level what how to write an app. This is, again, a very simple app. But what I recommend to you guys is that you go to the gallery. So you go here. And really, the first thing you should try is just go hit one of these things, run it, and see how it works, and then go download the code, right? I mean, the code for some of this stuff, this one's pretty simple, right? This is a pretty straightforward app. It's just using Gradio to host like a little demo. Well, my UI is not working. Or GitHub, maybe my network. And then if you go see the Muse code here, you can see how the whole system's built, right? You can see where the load balancing happens. You can see, let's see here. Yeah, you can see how the pre-provisioning is happening here. You can see where we're embedding safety filters and the load balancing logic and all that stuff here, right? So anyway, so I think that's the easiest way to learn is run something first, see how it works, change the code, tweak it. And once you feel confident that you're like, okay, I kind of understand it, then go read this. And then what you want to learn is Lightning apps in 15 minutes. And then you want to learn the difference between works and flows, right? Which I kind of already talked about it, right? We have these guides in both documentations that can actually take you through the levels. So basic skills here, I mean, there's a lot of people that use this stuff out of the box that are not engineers. So levels 1 through like 5 and 6 are really around kind of how to use all the basic stuff when you don't want to code stuff. So I would start with medium for you guys, intermediate skills. And here you get to learn how to build an app from scratch, right? And this is going to be the hello world, run the app, and then you're going to learn how to write your own components, how the event loop works, the difference between flow and work are, all of that. And then you're actually going to be able to like actually write your own work. I believe it happens here on the advanced part. Yeah, actually it's not there. Develop a lightning component here. There you go. And then just actually walk you through it. It's honestly easier to basically just copy a component like the Jupyter notebook and then change it. But at the end of the day, the TLDR is the flow is something that should be fast, right? So like there should be no state to it because it will slow down the system, right? And that was one of the questions asked. So the flow is just kind of coordination logic. Anything that's going to take more than like a few milliseconds, stick it in a work, right? And then the work's actually going to do that stuff. Okay, so we do have about 6 minutes left, I believe. So I just want to stop and ask, you know, if you guys have any more questions and just talk for a bit. All of this, again, is on lightning.ai. So documentation, this is kind of the hub of everything. And by the way, we have a community on Slack. So if you have questions or anything, I would definitely join this because we have over 5,000 people who are amazing at what they do. And they will actually come in and help you with anything. So let me give you a quick example of that, which is like, we have questions, right? So it's a cool place to just come chill, see what people are doing. But yeah, you know, you want to get better at what you're doing. You want to ask people who are professionals at this, and there's a ton of researchers here as well. Come ask your questions. We'll help you. You can contribute to Lightning as well, right? So it's very simple to get started. You go to the Lightning repo. Where's Lightning repo? There. So you go to Lightning repo, and then if you go to issues, we actually have a tag called like I think it's like new, good for new people. I believe this is a tag. Let's see, which one is it? Yeah, okay. There's a tag contributors or new issue. I really encourage you guys, it doesn't have to be Lightning, just in general. Yeah, this one, good first issue. And these are pretty simple things you can get started with. It doesn't have to be Lightning. I would just, in general, like encourage you to go contribute to open source because you're going to learn a lot by doing that. Anyways, thank you guys. Any questions? Anything else you guys want to, or not questions, just thoughts or comments in general?
Well, thank you, Will. So let's give Will a round of applause on the reactions. Wait, I guess there's no applause reaction, so I'm going to give you a coffee mug.
I'm drinking your coffee.
Okay, so one question about the infrastructure for Lightning itself. The flow abstraction seems very powerful and flexible. Is that something that the end developer would need to think about for synchronization if there's shared state? What is your anticipation of that? Are you going to build more abstractions on top of it for maintaining shared state?
No, so something that we are, sorry, one of the principles of Lightning is that you don't have to learn any framework, right? Now, there's obviously a little bit to learn here, but I already explained it, flow and work, that's all you need to know. So in PyTorch Lightning, we only had 2 abstractions, the trainer and the Lightning module. Once you learn those, you know how to do everything. Here you have flow and work, and then app is just something you start. So once you know flow and work, you can do anything. We're not going to be adding more things. That's the whole point. We want to make something super expressive. So in the code itself, whenever I assigned a variable, so when you saw there, if self.work. I don't know, value equals 3, every time you do a variable assignment in works, that's actually HTTP requests that we're doing under the hood, and we're moving variables around for you across machines. So you don't have to think about cross-machine communication. You don't have to think about moving data around or anything like that. So we've abstracted all of that away. So the first thing we built was the communication mechanism and the state sharing system. So there is nothing that we need to layer on top of it anymore, right? And we are, and you know, as you guys use it, you will find issues and you say, oh, it's hard to communicate this. Like we're working on cross-machine tensor communication specifically for model communication, right? So it's not enough to just send a request. Sometimes you actually have to send parameters of a model or something. So there are these pipelines that are in there as well. But to you, it's just variables, right? So you won't actually even see it. It just happens under the hood.
Okay.
We like to think like it's like a car. Like, I want you to be able to drive a Ferrari without having to understand all the fundamentals of the engine. But if you do want to, you can get in there and open it and change your engine, make your tweaks and tune it and do all of that, right? So even the code under the hood is well written and clear, and it's all documented so that developers can get in there and make changes and do whatever you want to it, right? If you don't like a mechanism, there was a guy who was doing reinforcement learning with this, and the state loop was too slow. It actually accumulated too much memory over time because we hadn't tested it on reinforcement learning. And so we had a memory leak, and he just went and like submitted a PR, cut it, and basically changed the setting for the event loop and then made it faster, right? So if you're frustrated or something doesn't work for you, really, please go submit a PR. We will help you land it. It's also great for, when you're applying to jobs and everything else. We've had plenty of people land at Google and Facebook who are contributors from our stuff. And so we're happy to help in whatever way possible.
Okay. One last question. Does Lightning handle larger than GPU memory models today? Like if I wanted to fine tune like a very large transformer and it doesn't fit on a GPU, there's like several tools that are now claiming to do like deep speed, FSTP, or are you just deferring to PyTorch FSTP?
No, so actually we were one of the first ones to introduce this. So let me show you here. FSTP. Yeah, there you go. So we actually were the first ones to implement deep speed into one of the libraries. So deep speed came out, and then they added it to PyTorch, but we then actually brought it into the system. So the way you used it for training, you basically come here. Actually, we have something called, I believe it's strategies here, where you enable them. So we have like 15 of these. We have Bagua, which is it's a library of different algorithms. We have HiveMind. So this actually lets you train on machines that are not even on the same cluster. Like you could use your DGX1 at home and my DGX1 at my house, and through the network we do this training. So kind of like federated without the privacy, right? Then we have DDP fully sharded, DDP strategy, DDP spawn. We have FSTP, deep speed, Horvath, blah, 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 blah. And we work tightly with all the cloud vendors. Like I was at Intel just a few days ago, and they're working on integrating like a lot of these strategies into Gaudi chips, right? And so we're helping them do a lot of this stuff as well. You can submit your strategies. These are pretty hard to build. Most of these have been built by meta engineers and the hardware providers. But if you're feeling ambitious, I'm telling you, you build one of these things, you will get the attention of all these cloud providers, NVIDIA, Facebook, Meta, and you'll probably be offered internships and stuff. So.
Okay, sounds good. So I think we are out of time at this point. Any other big questions from students? Wait, I see a comment there. Oh, it's about Meta. Okay, that's fine.
Terry Patstone. No, I left Buds in 2011. So all the guys, there was a movie called Act of Valor, I think. No, it was like there was a movie that they made back in the day. All those guys in there were my instructors. I don't know how they had time to film it, but it's like they did it there. So yeah.
Okay, sounds good. Thank you, Will. Appreciate you taking the time to come and talk with us and do this very impressive demo of Lightning. Congratulations again on all the growth and best wishes. Thank you again.
Yeah, thank you. See you guys on the Slack. Bye.
Bye.